Okay, calculus AB, we're going to do the derivative of E and the derivative of ln, sorry. So E is the natural exponential function and ln stands for the natural logarithmic function. And they're pretty easy, but they do involve a chain rule idea. So, you ready? This is where we're going to put the exponent. D over dx means the derivative, and then something should come after that. The derivative of can be in parentheses or a square bracket. The derivative of e to the f of x, so e to anything up here, a function, will equal, you ready? E to the f of x times the derivative of f of x. That's it, okay? Here's how you kiddos will probably memorize it. Ready? The derivative of e to the u equals e to the u prime times u prime. Okay? I don't know if you remember, but in your matching cards, there was one function that looked like this, and then the derivative looked like this. And some kids asked me, Miss Keener, those are the same. And I said, yes, they are, because the derivative of e is e. The derivative of e is e. You just have to multiply by the derivative of whatever's up here. You ready? Here we go. So, u prime, derivative f prime of e to the sine will be e to the sine times the derivative of sine. So what's the derivative of sine? Cosine. And then we should write the cosine in front. If I gave us enough room, cosine of x times e, and in the power is the sine x. Just barely. Okay. B. Ready? F prime will equal e to the u prime. E to the u, that stays the same, times the derivative of 2x plus 3. So derivative of 2x plus 3 is 2. Simplify by bringing the 2 in front of the e. 2 times e to the power of 2x plus 3. All right, C. What do you do if there's a number in front of the e? Well, then we're just going to multiply. So we have 3e to the u times u prime. What's the derivative of the power there? 2. So one step to simplify, 3 times 2 is 6, e to the 2x. Okay, what do you think we're going to do now that we know this? We're going to add in, there go my lights, we're going to add in product rule, power rule, no, product quotient and chain. Okay, remember product quotient and chain rule? All right, so what do we have here? Do we have a product? No. Do we have a quotient? No. But we do have an e is inside the square root. So let's do a rewrite step. This is not a derivative. This is a rewrite. F equals e to the 2x minus 6 to the 1/2 power. That's our rewrite. So now let's find f prime. So f prime will be 1/2 is going to come down in front. The inside stays the same. The inside stays the same. When we're using the chain rule, the inside stays the same. Subtract 1. So 1/2 minus 1 is a negative 1/2. Now we're going to multiply by the derivative of the inside. So this is pretty much a chain rule because, or a triple chain rule because the derivative of e has a chain rule part of it. You always multiply by that derivative. Okay, so we did the derivative of the outside. The inside stays the same. Now the derivative of e to the 2x minus 6 will be e to the 2x minus 6 times the derivative of 2x minus 6, which is 2. All right. What happens with the 1/2? 2 times 1/2 is the number 1, and this is a negative exponent, so we should move that to the denominator. Where should I write this? Let's go right here. So in the numerator, we have e to the 2x minus 6, and in the denominator, I have e to the 2x minus 6 to the power of 1/2. Wait a minute. What do you notice? What do you notice about the numerator and the denominator? Are they the same thing? So the numerator and the denominator, this is a power of 1, and that's how it's a power of 1/2. So what's 1 minus 1/2? Because we're dividing. So you could take this is to the power of 1, subtract 1/2, and we get e to the 2x minus 6 to the 1/2 power. Isn't that what we started with? Isn't that neat? That's the derivative. Okay, one little thing I'm going to show you. This is a power, right? And this is a power. Do you remember how to do power of a power? Can't we distribute and multiply? So we're going to distribute this 1/2 in here. What's half of 2x and what's half of negative 6? So that's our derivative. That was funny. Okay, interesting. All right, what are we doing on e now? Let's go to this e, step e on e. What do you notice about this? A product, right? So we're going to use a product rule, PR, fg prime plus gf prime. These little rules, they're easy to learn, but that means they're usually easy to forget, so we can't forget to use them. Here we go. F derivative, sorry, x squared, f, times the derivative of e to the 2x. So the derivative will be e to the 2x times 2 plus e to the 2x times f prime, derivative of x squared. Okay, remember what I ask you guys? I say, can you factor, can you distribute combined-like terms, or can you add fractions? And in this case, we can factor out the common factor, out, OUT, greatest common factor. So let's scan, do our scan. I see a 2 in both of them. Okay. I see 1x in both. This has an x squared, but this one doesn't. So a 2, an x, and an e to the 2x is in both. So the greatest common factor will be 2x e to the 2x parenthesis. Now I took all of this out of the first term. What would be left in that first term? An x, and if I took 2xe to the 2x out, 2xe to the 2x, then that's going to be left with a plus 1. All right, that's the product rule. I got to go to the next page. Okay, you're going to try, you try f, and you try g, and on f, that's going to be the product rule, and on g, what are you going to use there? Quotient rule. Okay, you try, this is product rule, and we're going to go to the back. Are you ready? Take a deep breath. Okay, natural logarithms. Ready? The derivative of the ln of a function. I mean, how many parentheses do we need here? Ready? The derivative of the ln of function is equal to the derivative of the function over f of x, the original function. Another example is instead of using the f of x, an easier way to memorize it would say the derivative of the ln of u. The derivative of the ln of u is equal to u prime over u. So those are two different ways to memorize it. Here we go. Ready? Find the derivative. F prime. The original function goes where? F of x goes in the denominator, 2x minus 3. And the derivative goes in the numerator. So what's the derivative of 2x minus 3? is 2. Sorry, that's it. Yep, that's it. I know you're wondering. That's it? Yep, that's it. Okay, the derivative. Ready? U prime over U, U prime over U, U prime over U. U prime over U. Any common factors? That's in everything. If you go, oh yeah, there's a 2. Nope, there's not a 2. Is there an X? Nope, there's not an X. Is there a 3 in everything? Nope. So we're done. Okay, what's the derivative of the ln? Derivative of the ln? U prime over U? Yes, U prime over U. Okay, so what's U prime? What's the derivative of cosine? So U prime over U. A derivative of cosine? Negative sign. Derivative of all the cos is negative. And cosine goes in the denominator. I wonder if that's a trig. Is that a trig something? That's a trig something, right? What is sine over cosine equal to? That's negative tangent, right? So the derivative of the ln of cosine is negative tangent. And you go, wow, how interesting. All right, we have 2 rules here now. This is going to be the ln. Let's rewrite. Oh, no, there's a shortcut. Oh, cool. Okay, rewrite this to the power of 1/2. All right, you guys. In the last 2 years, you did 3 logarithm rules, and one of those rules was a power rule. So if you have something to the power, you can bring that power in front of the ln. This is not a derivative. This is an algebra rule. 1/2 times the ln. I don't know why I did this funny. This is an L, okay, of the inside. Have we taken the derivative yet? No. Does it? Oh gosh, Katie, this is like my worst video. I usually don't make mistakes. Okay. How come we can do that? I don't know. That was from pre-calculus and algebra 2 or math 3, where you learned some logarithm rules. Would you like help reviewing those? Yes? Okay, hold on. Hi, I'm back, and remember this packet of formulas I gave you? If you don't have it, I have plenty in the classroom for you. But there's this one box that is going to be super helpful to you guys because it makes the calculus easier. And right here, do you see this? This is what the property I just used. If you have the log of something to a power, you can bring that power in front. We're also going to use these 2 things here. Okay? So check this out, highlight it, say I'm going to need this, you will need it, and we're going to go back to our example here. Now, I haven't taken the derivative yet, so let's do that. Let's take the derivative. First of all, I have a 1/2 here, and then U prime over U. So there's U in the denominator, and U prime. What's the derivative of 2x minus 4? Just a 2. And what do you notice about the 1/2 and the 2? They're going to divide out, and so we have 1 over 2x minus 4. Okay, so derivatives of ln and e, a little bit simpler than the product quotient and chain rule. And I have 1 minute, so we're going to finish. I'll do as much as I can on this one, okay? Low quotient rule, ready? Low d high. Oh, what's the derivative of if you just have an x? It's going to be 1 over x minus high d low all over the low squared. And when I take a derivative, I get the slope. So I'm going to plug in 1 to find the slope. So I have 4 times 1 times 1 over 1 minus the ln of 1 times 4 over 4 times 1 squared. Okay, the ln of 1, go back to your formulas. It was on there. The ln of 1 is what number? 0. So this is going to be 4 minus 0 all over 16, which reduces to, I'm out of time. And that's just the slope, so you got to finish it to find the line.